I'll record this one. So yeah, I was saying for those who dropped out of the link or could not connect today, that we need to prepare the classes in advance, and so read the main textbook, which is this one, Rybicki and Lightman. So for next Wednesday, up to section 1.6, but hopefully the whole chapter 1. And so the idea is to cover my course up to section 3 of chapter 1. Okay, and so again, the idea is for you to do the course. Okay, so I'll just try to answer questions. I won't go myself through my presentation. I'll ask you guys to go through it. Okay, so we'll do this randomly, and if nobody wants to, I'll ask one of you to do it. Okay, so I choose randomly also. Okay, and the idea is to have 3 or 4 students describe the lecture each Wednesday. Okay, and then hopefully we'll go around everybody. So this is the main textbook, but it might not be enough to understand everything. So there is another one, Borer and Huffman. That one is more to do with the chapter on scattering and diffraction. So this is a more advanced chapter. I'll remind you when you need to go through this one. It's still got very nice introductory material. Let me, if I remember well, yes. This is the standard textbook for scattering theory, but it's also very useful to understand the propagation of electromagnetic waves into a medium. So this is, for instance, the description of this imaginary refractive index. Okay, so the refractive index with an imaginary part which accounts for absorption into the material. So this is the origin of extinction. For now, for chapter 1, you shouldn't need this book, but I'll upload it to my FTP so that you can download it quickly, and then I'll remove them. Okay, because of course there's copyright issues here, and we shouldn't be sharing PDFs over FTP directories. So please, when I upload them, download them immediately. In a couple of days, I'll then delete the PDF files. So that's another important textbook. And there is another one, which is, I think, yes, Shu. So this is the book by Frank Shu. It's very compact, very difficult to follow, but you see, in only 9 pages, they cover what Rybicki and Lyman do in, I think, 30 pages. And they use the vectorial notations. I mean, Frank Shu uses vectorial notations, but you see, I take some of the material from my own summary here. So you can tell that this is these figures here I'm borrowing from this textbook. And you see, one thing that's nice about Frank Shu's book also is that he explains the origin of the theory. So that's nice. It's not always available in the textbooks. You know, when material becomes standard and you know, when topics become like standard topics and they go into textbook, people forget where they come from. Well, you know, this is theory from Chandrasekhar in his book from radiative transfer. This is where everything comes from in the radiative transfer theory. I very much recommend to read this one too. So the most important standard reference is Rybicki and Lightman. But this is not the only one you have to read. You also have to read chapter 1 of this other textbook. And so you can see that they use vectorial notation. I mean, Frank Shu uses vectorial notation, which can be a little bit difficult to digest at some points. But please go through this because there is something like, for instance, the phase function, like this the treatment of scattering is absent in Rybicki-Lightman. Rybicki-Lightman does not use the phase function. They only use isotropic scattering. And that's a real problem because nowadays in 2022, a lot of time has passed since Rybicki and Lightman wrote their book in the 90s, or even in the 80s might be, I'm not sure, but in the early 90s, late 80s. And one of the things that has developed since the time that Rybicki and Lightman wrote their book is the importance of scattering. Now people recognize the importance of the phase function here. So this is something that's missing from the standard textbook, and it's available here in Frank Shu's book. Okay, and a third, sorry. So we have Rybicki and Lightman, Bayer and Huffman, Frank Shu, and then a fourth and final source of material is a manual for a radiative transfer package called RadMC3D. So this is very handy. RadMC3D is a package to basically solve the radiative transfer equations in any medium. Okay, so we know when we'll do at the end of the chapter, we'll see that solutions to the radiative transfer equation. And how do we connect emission from emission through a complex medium with what's observed? So you know, when you observe a star or a nebula, the sources of emission inject photons into the medium, which are transported through the medium towards the observer. Okay, so what you observe on the telescope is the transfer of radiation through the medium. Okay, and so this is what this package does. You can define a grid, a three-dimensional grid for instance, the gas density in different phases, ionized or molecular. You know, the 3D distribution of the different species, so meaning like ionized hydrogen or carbon monoxide or whatever, I mean, like molecular hydrogen, helium. And so each of those species would have a 3D distribution, and this package calculates the equilibrium temperature first, and then uses this temperature field to compute the transfer of radiation through the grids that you give it as an input. Okay, and so this leads to the emergent intensities and predicts the observed images. Very important package to do radiative transfer. It's in use in very many different fields in astrophysics. It's not the only package, but I like this one very much. It's very well tested, and I recommend this because of these two chapters. You see, you have chapter 6 and chapter 7, and so if you go to chapter 6, I think here it is. You have a summary of the theory. So, okay, this is a manual to run a package, okay? Might not be what you could think of a textbook, but it's actually very handy. Every time I have a doubt about, oh, so how was this radiative transfer equation? How do we put the scattering coefficient? I forget. I go to this one. This is what I do. I don't use the textbooks. I prefer to go to this manual because I think the information here is very well condensed. Sometimes I use my own summaries, but this is really handy, I think. So it's very well presented. It's very compact, you know, and so I recommend using this. And the whole chapter 1 is basically that. I mean, like one page. Okay, so super summary. And then there is the other chapter 7 on so this is the definition of the scattering matrix, for instance. Topics we'll see in the more advanced version. See? Hola, Carla. And so yeah, so this is still on the dust radiative transfer, and then chapter 7, the lines. Okay, and so you see you have a summary of the line, the radiative transfer from line emission. And so basically these are the sources of material I'll be sharing with you, so that you can learn yourselves, basically. And then the idea is that we discuss the material, okay? So I'll be uploading this this afternoon or tomorrow morning at latest. And so you can have a good week to prepare chapter 1, and meaning chapter 1 from my summary. Remember, what I think you should know is my summary, okay? So it's a selection of the material from the textbooks I've just shown you. Apart from that, the idea is that everyone finishes this course in excellent conditions with good grades, but I also need everyone to work. And so one way to force this work is for you to do homeworks. So you'll have to do a series of homeworks. For chapter 1, the homework is super simple. It's all of the problems from Rybicki and Leitman chapter 1. But for the other chapters, let me give you an example. So Silvio is asking Radex. Oh yeah, it's Radex is similar. Is Radex is only for a uniform slab, I think, if I remember correctly. There's an online version of it, which I use sometimes. It's LTE, local thermodynamic equilibrium, also, Silvio, if I remember correctly. But this is more general. And actually, if my memory is correct, the author of RadMC3D is also one of the authors of Radex, I think, Kees Doulemont. Let me show you the homeworks for the other chapters, so we can go through this. Or okay. So chapter B. Yes, you see, I have some tareas. Tareas in Spanish means homework. Okay, so the idea is for you to do all of these. Now I'll remind you of this when we go through when we get into chapter 2. Okay, but for now, the homework for chapter 1 is just all of the problems at the end of chapter 1 in yeah, you see these problems in page 43 pages to do chapter 1, and Frank Shu does it in 8 pages. So you can imagine that it's quite, Frank Shu is really condensed. Let me get there anyway, just to show you the problems. Because yes, it's important to have those problems done before we go on to the other chapters. So at the same time as so these are the problems, right? There is problem 1.1 to 1.10. It's 10 problems, okay? These are standard problems you should know. And so the idea is for you to finish those problems before we get into chapter 2, okay? Because otherwise, there's, I mean, you'll be distracted going back to this topic. So in addition to the homework, I'll also do I'll also ask you to do 2 controles probably one final exam. I'm not sure about the final exam. I've realized one thing, you know, that maybe it doesn't apply to all of you, but those who are starting the PhD will have to do a qualifying examination. And I've realized that when students reach the stage of a qualifying examination, they've forgotten everything. Like, you know, and they do this course 1 year and then the next they've forgotten. Okay. And so I think that maybe one way to prepare for this qualifying exam would be to have the qualifying exam for radiative processes at the end of the semester. Okay, so this way you don't have surprises when you get there. Okay, and you know what would be the topic of the qualifying examination. So this, I think, is a good idea. I mean, personally, I'm not. I'm fond of this qualifying exam. I'm against it. I think it's a waste of time for the students. You get very stressed with the qualifying examination. And instead, in my opinion, you should have a very serious exam to do with your thesis. I mean, your research work. That's what is important in a PhD. And so you should have a very rigorous exam, but connected on your thesis. That's my opinion. Unfortunately, I'm a minority, and so most of my colleagues here think that you should have like a traditional qualifying examination. Same as in the United States universities. So like a qualifying examination connected to standard coursework. And so even though I don't like it, I think I have to prepare you for this. And I've just realized, because of the qualifying exam that's just passed, that some of my students who did the course with me were not prepared to answer my own questions. So this is why this semester I'll also do an exam. Even though you do great in the two controls, control is an interrogation. It's like a midterm interrogation, if you want, a midterm exam. Even though you could do great in the homework and in the midterm examination, I'll ask you to do the exam anyway, so you can be certain that you'll do right, you'll do okay for the qualifying exam. Okay. So I don't know if you have any questions, Diego. You seem to be wanting to say something.
Do you hear me?
Yep.
Can you hear me?
Yep.
So is the qualifying exam or the final exam that we will have like oral exam? So you will ask questions to us live, or is it a paper exam on paper?
Yeah. So my goal is to do it on paper, like not oral. Like if you want the oral presentation part will be every Wednesday, and 10%. I'll also assign 10% of the final grade according to your participation and your performance in every Wednesday. So I'll keep track of this. I'll formulate a completely subjective grade as to your oral performance. But that's going to be a good grade. I mean, the only way to have a grade below 4 is if you do not attend classes. Okay. So that's going to be the oral part. So it's going to be every Wednesday. So I need you to be prepared. Okay. Otherwise, it's going to be very embarrassing for you for yourselves. Like if you're not prepared and I ask you to prepare a section, you will, it's going to be a very embarrassing situation for you. Okay.
Yeah. Right.
Yeah. So you need to be prepared. And so this general every Wednesday participation and going through the lectures, explaining it to your fellow comrade students is going to be very helpful to improve your presentation skills and explaining things also. Okay. And so this final exam is going to be general questions on the course. The type of questions that I put, because normally you'll see that the midterm in controllers are going to be more difficult than the final exam. The final exam is going to be more general questions. But the problem is that if we don't go through this, and I ask general questions 2 years later, normally students have forgotten everything, you know. So that's the plan. So I don't know if you have any other questions. I'll be sending a summary of what I said today in terms of the evaluation of the course by email. So this stays somewhere. So the fraction of 20% homework and 10% presentation, and the rest is going to be controllers and the exam. Okay. I don't know if anyone's got questions apart from this. No.
Professor, I have a question. Can you hear me?
Yep.
So about the format of the classes, when we have to explain to our classmates the contents of the course, do we have to have prepared some material? I mean, like visual material that could be more useful for understanding the contents, or maybe just projecting the PDF to the class or something?
Thanks for asking this question, Benjamin. I think there's already a lot of work. I mean, like going through, you'll see that going through the textbooks is going to be a lot of work. Okay, but there might be instances where you find something particularly interesting, or maybe you found another source of material. You know, maybe you found a better way to present things. Okay, because perhaps in another textbook, say Carroll and Ostley, or maybe you found a figure which is much better than what I have in my summary at explaining a specific topic. Okay. In this case, you're more than welcome to use your own presentation. And if you do so, I recommend to inform me in advance that you want to present that day, so you can be sure that you'll get the chance to present and use the material. Okay. So if you are very well prepared, and you say, oh, this is something I really want to explain, and I think it's very interesting. So for instance, when we reach especially the topics on high energy astrophysics, like to do with the synchrotron radiation and Compton scattering, and where I'm not an expert in, then I'll really welcome if you have a specific example, say, radiation from a supernova remnant you want to show us, then that'd be great. I mean, I think that's especially if you have concrete examples. So yeah, the answer is that you're welcome to do so, Benjamin. Okay, but I'm not expecting this of you because there is already a lot of work to do.
Okay, thank you.
¿Alguna otra pregunta? Any other questions? So for next Wednesday, I would prefer to meet in person. Okay. What I'll be doing is, if nobody's got a specific presentation, I don't expect you to have a presentation for next Wednesday, because this is really standard stuff. But I mean, if by default we'll be using my my summary, I'll project the summary on screen, and then we can go through it. However, I'll also allow those who are abroad or couldn't make it to Kalan to join online, but I'll just turn my laptop on, and then you can connect and try to participate remotely like this. Okay, so for those who are still in India, then you can drop in and participate in the discussion. Okay. I understand that it's not going to be easy to present to the others if you are away, but we can try. Maybe we can find a way for you to share screen, for instance, and have you explain the PDF on your screen, which I'll be projecting with a data show. Okay. So in summary, even though you are away in India, please be prepared that perhaps you have the chance to present to the one part of the course also. Okay, so this is a way for you to feel involved in the course, even though you're away, and even though I will be meeting in person. Okay. So in summary, I'm not trying to do a really hybrid course. It's more like just live course where I'll be allowing you to participate remotely. It's not going to be ideal. It may be difficult to hear everything that's said in the class, but we'll try. Okay. Let's see how it goes. So if there are no further questions, then please do your best to prepare what I've just explained, and we'll meet next Wednesday then at 10. Okay. Good then. I say goodbye and bye.
Bye, everyone.
Bye bye.
Bye.
Abigail, si quieres, vente para acá. Chau.